power series. For each series below, find the interval of convergence and the radius of convergence. All right, so we've got x to the n over n plus 1 factorial. We're going to start out using the ratio test. Remember that x in this case is a constant and n is my variable that I'm dealing with. My a sub n is x to the n over n plus 1 factorial, and my a sub n plus 1 will equal x to the n plus 1 over n plus 2 factorial. So when we're going to find the limit as n approaches infinity of a sub n plus 1 divided by a sub n. I have a feeling I'm going to majorly run out of room on this one. All right, then we're going to multiply by the reciprocal. Whoop, so the reciprocal of that would not be that. It would be n plus 1 factorial over x to the n. And I notice my x to the n's are going to cancel out, so I'm just going to be left with an x on the top. And my factorials will cancel out all the way up to the n plus 2. All right, so when I go to plug in infinity on this one, I'm going to get 0. All right, and with the ratio test, we're looking for our answer to be less than 1. I notice that 0 is always less than 1. It does not matter what x is. I can let x be 1, 1,000, 1,000,000, and I'm still going to get 0 as my answer. So this one is always going to converge. So my interval of convergence will be negative infinity to infinity. And then my radius of convergence is going to be infinity, and that will do it. All right, next one. We've got negative 1 to the n plus 1, x minus 5 to the n over n 5 to the n. This looks like lots of fun. And what we're going to do on this one is, once again, I'm going to use the ratio test. I suppose if you really wanted to use the root test, you could, but I'm just going to stick with ratio here. This will be my a sub n, which means my a sub n plus 1 will equal negative 1 to the n plus 2 times x minus 5 to the n plus 1 all over n plus 1 times 5 to the n plus 1. All right, so now we're going to find the limit as n approaches infinity of a sub n plus 1. So negative 1 to the n plus 2 x minus 5 to the n plus 1 over n plus 1. This just looks like it's getting a little messy. And then we'll divide by a sub n. Whew. Over n 5 to the n, which means I'm going to multiply by the reciprocal. So I'm going to get n times 5 to the n over negative 1 to the n plus 1, and then x minus 5 to the n. All right, so let's see what is going to cancel here. With my negative 1s, I notice the n plus 1s will cancel. I'm going to be left with a negative 1 up top. My n, nothing is going to cancel with that. Let me see my x minus 5s. My x minus 5s, the n is going to cancel, but I'll be left with just x minus 5. And then, like I said before, my n is not going to cancel up top. The 5, this will cancel down here, so I'll be left with the 5 down below. So down below, let's see, I'm going to have n plus 1 left, and I'll have the 5 left. Okay, so as I let that approach infinity, remember we're letting n approach infinity, I will get infinity over infinity, which means, let's see, we're going to find the limit. Continue to keep going here. We're going to use L'Hopital. And if I do that up top, I'm going to be left with negative 1 x minus 5. And on the bottom, I'm going to be left with 5. So everything is dropped out. I know that I need the absolute value of this to be less than 1. So I am going to, first of all, the negative is not really going to make a difference because we're taking the absolute value of it, but I'm going to multiply both sides of this by 5. So now I'm going to have x minus 5 is going to be less than 5. And now remember the way that we're going to write this is negative 5 is less than x minus 5, which is less than 5. And then I'm going to add 5 to both sides. So I'm going to get 0 is less than x is less than 10. Okay, so that's pretty much my interval of convergence but we do have to test our endpoints. So testing the endpoints. First of all, let's test x equals 0. So if I put 0 into this whole big formula for the x, I'm going to get negative 1 to the n plus 1. And then if I put 0 in there, I'll have negative 5 to the n. And then this is going to be over n times 5 to the n. Interesting. All right, I'm going to try to rewrite this because of this negative. I can separate this as negative 1 to the n plus 2, and then negative 1 to the n, and then 5 to the n, all over n times 5 to the n. My 5 to the n's are going to cancel. These two I can combine because they have the same base. So if I add the exponents, yes, n plus 2 plus n will be negative 1 to the 2n plus 2 over n. And I noticed anything to an even power, 2n plus 2 will always be an even number. This will just be 1 over n, which means that this is a power series. And p is equal to 1. And since that is less than or equal to 1, this is going to diverge. So 0 does not work. So let's test our other endpoint, which will be 10. So if I test 10, we'll get negative 1 to the n plus 1. And then if I plug 10 in, I'll get 5 to the n over n times 5 to the n. My 5 to the n's will cancel. I notice I'm left with this, and this is an alternating series. So if I do my alternating series test on this one, test 1, u sub n will be positive, because u sub n is just 1 over n in this case. 2, my derivative of 1 over n is going to be negative 1 over n squared. That will always be less than 0, so that worked. And then 3, we've got u sub n approaching 0. So if I find the limit as n approaches infinity of 1 over n, that does equal 0, so all 3 checks work. So yes, it does converge, so we get to include 10 in our interval. So that is my answer. It did ask me for the radius. The radius, remember, we just take 10 minus 0, which is 10, divided by 2. My radius is 5. And there we go.